Given the rational functions h of x equals 6x squared plus x minus 1 over 6x plus 3, and k of x is equal to 9x squared minus 1 over 15, find the new function h over k of x and the new domain. So let's write step 1 and step 2. We're going to write h over k of x is equal to h of x over k of x, which is equal to h of x divided by k of x. But we can write divided by as multiplied by the upside down, the reciprocal of k of x. So replacing the rational functions, we have 6x squared plus x minus 1 over 6x plus 3, and then turn the other dude upside down because we're multiplying by the reciprocal. So we're multiplying by 15 over 9x squared minus 1. So we're multiplying rational functions. We're supposed to change we were actually dividing first. Dividing by a rational function, step 1, write the division. Step 2, change division to multiplication, flip the second guy upside down. Now we're ready to do top times top over bottom times bottom. Let's factor everything. We'll 3 times 5 is the 15, and let's rewrite 9x squared minus 1 as 3x squared, 3x parenthesis squared minus 1 parenthesis squared. See, we're trying to get ready to use a formula on the bottom in a few moments. Now, up on the top we have 2x plus 1 times 3x minus 1. On the bottom, 3 times 2x plus 1. You see, on the bottom here, we're trying to use a squared minus b squared equals a plus b times a minus b. Okay, multiply everything across the top, all the factors, and all the factors across the bottom of this fraction. 3 times 2x plus 1 times 3x plus 1 times 3x minus 1. That's the application of the formula, a squared minus b squared. Cancel all the common factors on the top and bottom and see what you have left. We have 5 on the top over 3x plus 1 on the bottom. That is the simplified form of h of x divided by k of x. Now let's talk about the domain. Let's see, for the domain of h, look at the h function. The domain of h is found by all real numbers x such that the denominator 6x plus 3 is not equal to 0. Well, let's solve for x. Move the 3 over, and we have 6x is not equal to negative 3. And now divide both sides by 6. We have x is not equal to negative 3, 6, which simplifies to all real values x such that x is not equal to negative 1/2. That is the domain of h. Okay, what about the domain of k? K is a set of all x's such that the bottom is not equal to 0. The bottom of k is 15. Well, 15 is never equal to 0. So this restriction is true for all x values, which means there are no restrictions on the domain of k. It's all real numbers. So at this point, we want to recall how we were finding the domain of a new function formed from two rational functions. We were taking the restrictions on the first function and taking the intersection of the union of the restrictions on the second function. So here we have the restrictions on the first function is x cannot be equal to negative 1/2. There are no restrictions on the second function, so all we have are x is for our domain so far is that x cannot be equal to negative 1/2. But there's a new problem here. Our simplified form of the function, you see step 3, has a denominator of 3x plus 1 on the bottom of the fraction. Well, we have to make sure that's not equal to 0 either. So we also must have the bottom of our new function, which is h over k of x equals 5 over 3x plus 1. We have to have that bottom never equal 0. Okay, we have to have no zeros in the denominator. So we're going to throw away the x's that make the bottom 0. What are they? Well, 3x plus 1, which is the bottom, cannot equal 0. Now all we're going to do is move the 1 to the other side by subtracting it from both sides. We get 3x is not equal to negative 1. Now get rid of the 3 by dividing both sides. X cannot be equal to negative 1/3. So we have a new restriction on our domain. Not only do we have that x cannot be equal to negative 1/2, It also cannot be equal to negative 1/3. The conclusion then, the domain for our new function h over k of x is the set of all real values x such that x cannot be equal to negative 1/2, comma, x cannot be equal to negative 1/3.